Okay, welcome to the video for 7.5. 7.5, we're going to be looking at, first of all, the graph of the inverse secant, cosecant, and cotangent. So if you look at this graph right here, you can see how the sine wave would go through this. And, when you're dealing with an inverse, this has really been rotated. And rotated to get that. And remember, the cosecant graph kind of sets on top of the sine like that. So imagine in your mind rotating this like at 90 degrees, and then you'll kind of see the graph of a cosecant. Now, the reason that we don't have this part right here is because that would fail the vertical line test, and then this would not be a function. So we have to, by definition, restrict the range on this. So basically what we have is the range of an inverse cosecant is going to be from negative pi over 2 to 0 to pi over 2 like that. And again, if you do the cosecant of theta, by definition is r over y. So what happens on this is we have a problem when y is equal to 0. If y is equal to 0, we have a 0 denominator. So we have an asymptote there. So that's why we have parentheses on the 0, is because you would be undefined right there, okay? If you're looking at y equals cosecant of theta, the range, remember the way the range works is the range is numbers larger than 1 and numbers smaller than -1. And when you're dealing with an inverse, the range turns into the domain of its inverse. So notice that's where this comes from, okay? So things that are kind of important about an inverse cosecant is the domain and range, and the quadrants based on this domain are going to be in quadrant 1 and quadrant 4. Based on the range are going to be in quadrant 1 and quadrant 4. So this is quadrant 1, and then this is a negative angle that's in quadrant 4, okay? So those are kind of the important things about an inverse cosecant. Okay, moving on to the inverse secant, here's what the graph looks like. Again, you can kind of visualize the cosine graph in there, and the same basic idea. You can see the graph of the secant, and if you can imagine rotating this at a 90-degree angle, then you would have a graph of a secant. But again, the reason that we chop off these pieces is because that would fail the vertical line test, so it wouldn't be a function. So that's why we restrict this the way that we do this. And the way this goes, a couple of things on this. If you have a secant theta, if you have that function, well, the range of a secant is just like it is on a cosecant. It's from 1 to infinity, all numbers bigger than 1, and all numbers smaller than 1. Okay, so when we do an inverse, the range turns into the domain. So that's why the domain of an inverse secant is negative infinity to -1, and then 1 to infinity like that. The range goes like this. It's going to go from 0 to pi over 2, and then pi over 2 to pi. So one thing that you may remember about when you look at an inverse cosine, the inverse cosine, the angles are going to be on the interval 0 to pi. So we have the same thing here. However, we have to exclude pi over 2. And the reason we do that is because the secant of theta, by definition, is r over x. And if x is equal to pi over 2, then, or x is equal to 0, then you're undefined right there. Okay, so we have to be careful about the definition of a secant. So we're going to have the same thing, the range of an inverse cosine 0 to pi. It's the same thing on an inverse secant, except you have to exclude the pi over 2. And the cosine of pi over 2 basically is 0. And since the secant of theta is 1 over cosine of theta, then we can't do 1 over cosine pi over 2 because you'd have a 0 denominator. So what you end up having here is you have quadrant 1 would be this piece right here. Quadrant 2, whoops, I'm highlighting the wrong thing. So quadrant 1 would be here, and quadrant 2 would be there. Okay, so the key thing on this is to get an understanding of where the graph comes from, why we have the range that we have, and why that we have the domain that we have. Okay, so let's move to the inverse cotangent. So the inverse cotangent, you can imagine rotating this at a 90-degree angle, and then you would visually see the cotangent graph on that. So the way this works on this is the range is going to be 0 to pi. The domain is going to be negative infinity to infinity on that. Okay, again, if you have a cotangent of theta, its range, remember the graph of a cotangent kind of looks like that, and its range is all real numbers. So the range turns into the domain of the inverse like that. Okay, and since our range is 0 to pi, we're going to be in quadrants 1 and 2, and we exclude those. Remember that the cotangent of theta is 1 over the tangent of theta, and what happens is if you do the tangent of 0, the tangent of 0 is 0, and the tangent of pi is also 0. So you cannot have a 0 denominator. That's why the parentheses are in that range. Okay? So here's a summary of this. These are the things that are the most important, I think, on here. And like if you're going to take some higher math like calculus 2, inverse trig functions actually show up quite a bit. So when you have an inverse secant, you want to know that basically what this means, and then this information here is giving you the range. If it's an inverse cosecant, this gives you the range. If it's an inverse cotangent, this gives you the range like that. That's what's really important about working with inverse trig functions. Okay, so let's go down to these examples at the bottom. And I want to take you through how to work these out and get an exact value. So the first thing you have to understand is what this problem really is saying is it's saying the cotangent of some angle is equal to the square root of 3 over 1. Okay, and it's real helpful to look at a unit circle. So I'm going to pull up a unit circle and we'll utilize this to help us reason this out. So the first thing is you have to write these things like this. So when you're doing part B, step 1 is just to write this as cosecant of some angle equals -1. Same thing with this one, you write secant theta equals -2. Okay, and it's a good idea to put whole numbers over 1 because you're going to be looking at definitions. So basically the definition of a cotangent is x over y. So you want to look on the unit circle and you want to determine where this x over y gives you the square root of 3, okay? So basically, if you look at a cotangent, the cotangent's range is going to be on the interval 0 to pi. If you have a positive number, since you have positive square root of 3, this means you're going to get a quadrant 1 angle out of this then, okay? And your job is to find that angle. So if you look at your unit circle, you know you're in quadrant 1, this is where this happens. So if you do the cotangent of pi over 6, that's equal to x over y. And notice if you take that x value, square root of 3 over 2, and divide that by the y value, the 2's would just cancel out, leaving you square root of 3. So that means the answer to this problem in radians is pi over 6. And I'll show you kind of how you can check these on a calculator here in a few minutes too. So that's how I reason that out. Okay, the next thing is the inverse cosecant. So rewrite it as cosecant theta equals -1 over 1. the definition is r over y. Now, because we have a negative there, and r is always positive, you want to rewrite this as cosecant theta equals 1 over negative 1. So r is going to be 1 in a unit circle, y is going to be negative 1. So if you look at your unit circle, the things that you have to pay attention to is you have to pay attention to the range. The range of an inverse cosecant is negative pi over 2 to pi over 2. So you're only considering this region and this region here. You don't pay any attention to any angles that are outside of that range of negative pi over 2 and pi over 2. Okay, so you look at where is y negative 1. Here's where y is negative 1. And again, you don't give the angle answer 3 pi over 2 because it's out of range. What you have to do is give something that's in range. So the coterminal angle to that would be negative pi over 2. Okay, you must fit in this range if you're doing an inverse cosecant. So the answer to this problem is negative pi over 2. Okay, all right, so that's how that's going to go. All right, so pay attention to these ranges. It's super important you're doing that on these problems. Okay, so the next thing is the inverse secant of negative 2 can be written this way. And again, what you have to do on this is you got to think about, okay, what is the definition? It's r over x is what that definition is. Okay, so this one right here, first of all, you know in a unit circle r is equal to 1. So it might confuse you a little bit at the beginning here, but the definition is r over x. So what you have to do is an inverse secant, its range is 0 to pi. So this is what's really important on this problem, is the angle answer must be between 0 and pi radians. So since you have a negative number right there, that means that you're going to have to be in quadrant 2. So if you're doing an inverse secant, you're either in 1 or you're in 2. Everything is positive in quadrant 1, so you know that you're in quadrant 2 on this problem. Remember, the cosine is the x value. Okay, so you can think of this problem this way. The secant of theta, the identity is that it's 1 over cosine theta. So notice if we do secant theta equals 1 over, and if we do the cosine of 2 pi over 3, then notice what we're going to get is we're going to get 1 over negative 1/2. The cosine of 2 pi over 3 is the x value. And then this is really just 1 divided by negative 1/2, which is equal to 1 times 2 over negative 1, which is equal to negative 2. So that means the answer to this is 2 pi over 3. Okay? So that's how you come up with that. That's how you would analytically look at a unit circle to make that determination. Okay, now every one of these things is checkable on a calculator. So I'm going to show you how to do this. It's actually easier to me to look at this in degrees. So pi over 6 is 30 degrees. Negative pi over 2 is negative 90. And then 2 pi over 3 is 120 degrees. So let me pull up my calculator and show you how you can check the answer to these problems. And what I'm going to do is I'm going to put my calculator in degree mode. I'm already in degree mode. So what I'm going to do is clear everything off. If you do a cotangent, you have to basically write this like this if you're doing this. So the way you would have to check this is like this. Okay, so this is how you check your answer. Now my calculator is in degree mode. And what I'm going to do is, you don't have an inverse cotangent key, but you do have an inverse tangent key. And we know the tangent is the reciprocal of the cosine. So you can go second tangent to get inverse tangent to come up, but then you don't put in square root of 3, you put in the reciprocal of square root of 3, like that. And now let's see if that doesn't give us pi over 6. Now it'll give you 30 degrees because my calculator is in degree mode. So see, that is how you can check and verify that answer. The next one is the same way. You're going to go second sine to get inverse sine to come up. Now, the reciprocal of -1 is still -1, so it doesn't really matter on that. And then if you put that in, you're going to get -90. So the calculator is programmed to pay attention to the range of the inverse trig functions. So you can do that. And then the last problem, you have an inverse secant, so do inverse cosine of the reciprocal. So I'll put in 1 divided by -2, and this should give us the 120 degrees, okay? So it's easy to check on your calculator, and that's an important thing to do when you're doing homework and so forth. Okay, next thing we want to look at is just how you do some stuff on a calculator. Okay, so the way I like to go ahead and start this problem is I like to write this as secant theta equals 5.4. Okay, because what you're trying to do when you do an inverse trig function, you're getting an angle. Now, we can change this to the cosine. The cosine is the reciprocal of the secant, so we just write that like that. And now on the calculator, we're going to put in theta equals inverse cosine of 1 divided by 5.4. Okay, and if I put that in, should give you the answer, and then we can just round this off. So let's see, go inverse cosine. Now I want radian mode on this, so I want the results in radians. So I need to change my calculator to radian mode and do that. Now I can go through and get everything entered. So if I go inverse cosine of the reciprocal, 1 divided by 5.4, this will give me the angle answer in radians. So I'll just round that off. I think I'm telling you in this to round to 2 decimals. So we'll round this off to about 1.38. Okay, like that. And all these problems are done the same way. Okay, next one, write this as cosecant theta equals -2.5. Change it to a sine. The sine is the reciprocal of the cosecant, so do that. Now go to your calculator. You're going to put in the inverse sine of -1 over 2.5 to get what that angle answer is in radians. Okay, so I'll put that in real quick. And we go inverse sine of -1 over 2.5. And then this is going to give you about -0.41. Okay, that's how that goes. And then the next problem, this is saying cotangent theta equals 12.4. So rewrite this as the tangent of theta equals the reciprocal. And then you can go to your calculator, and then you can do the inverse tangent of the reciprocal to get your answer in radians. So second tangent, get the inverse tangent to come out, do the reciprocal, 1 over 12.4. Okay, and then the answer to that problem is going to be about 0.08. Okay, so you want to know how to work these things out whenever you're doing an inverse secant, inverse cosecant, and inverse cotangent, and you got to rewrite those using the reciprocal. Okay, let's go to the next page. The next page, we're going to work with composition of functions. So to begin with, I'm just going to do a couple of triangle problems to review on here. So we're going to find theta in these two triangles. So first of all, look at theta, talk out what you have. You are given the opposite over the hypotenuse. And remember, the sine of theta is equal to the opposite over the hypotenuse. So what we'll do is we'll just write this as sine theta equals 7 over 10. Okay, you have to use the calculator to get this. So what we're going to do is we're just going to do the inverse sine of 7 over 10 on the calculator. And this should give you, that's a positive number. Whenever you're dealing with right triangles, all of the sides are positive, so you're going to get some kind of an acute angle, which is in quadrant 1. So I want to go back to degrees on this. So I'll press my mode button. I'll go back to degree mode since we're dealing with triangles. And then what I need to do is just go like this. So just clear everything off. Then I go inverse sine of 7/10. This will give me the acute angle. So that will give about, we'll round that off just to a decimal place. So that's about 44.4 degrees would be the answer on that. Okay. All right. Then the next thing we want to do is let's just look at what this other triangle is telling us to do. So talk out what you have in relation to this. What you have is you have the side opposite, and then you have the side adjacent. Okay, so we learned that the tangent of theta is equal to the opposite over the side adjacent. So we can write this as tangent theta equals the opposite 12/19. And then we can do the inverse tangent. So you just take your calculator, do the inverse tangent of 12/19, and then we'll round that off. This will give us a degree answer on here. So in degree mode, do inverse tangent, 12/19, and this will give you an acute angle of about 32.3 degrees. I'll just round that off like that. Okay, so you have to use your calculator to do this. We've looked at some right triangle problems before. So the next thing we're going to do is a composition of functions. What you have to look at here is you have a function inside of a function. So cosine theta is going to give you what you're doing the inverse sine of. Over here, the function inside is the sine pi/3. Whatever the sine pi/3 is, you're going to do the inverse cosine of that result, and so forth. Okay, one of the things we're going to try to do on this is we're going to try to do this without a calculator. So let me pull up a unit circle. Okay, so I've got a unit circle pulled up here. First of all, the range of an inverse sine is on the interval in radians. It's on the interval -pi/2 to pi/2. So when we get an answer to this problem, our answer has to be within -pi/2 and pi/2. So first thing we're going to do is just go to the unit circle. We're going to do the cosine of pi. Okay, so we look at pi radians. The cosine is the x value, so that gives -1. So that means that what we need to do is we need to do the inverse sine of -1 on this range. So the only place on a unit circle where y is -1 is there. So what you're doing again is you're just asking the sine of what angle is -1. Okay, remember the sine is the y value in a unit circle, so the sine of 3 pi/2 is going to be -1. But 3 pi/2 is out of the range, so you have to go this way. So the answer to the problem would be theta is equal to -pi/2. So you have to make sure that you're in that specified range of an inverse sine. So that's how you work that out. Okay, and I'll show you how to check this on a calculator here in just a minute. Okay, next problem. Again, we're doing an inverse cosine. The range of an inverse cosine is from 0 to pi, meaning you're in quadrant 1 or you're in quadrant 2. Okay, so the first thing we need to do is do the sine of pi/3 on a unit circle. Pi/3 is here, the sine is the y value. So the sine of pi/3 is going to be square root of 3/2. So we do that. Now that means we're going to do the inverse cosine of square root of 3/2. And what this really means is the cosine of theta equals square root of 3/2. So remember, the cosine is an x value. So we need to look from 0 to pi and figure out where x is square root of 3/2. That happens right here. So that happens at the angle pi/6. So that would be the answer to that problem. Okay, just make sure that you're within that range. Okay, now we got the tangent. So on this problem C, the inverse tangent has a range negative pi over 2 to pi over 2, excluding those two. So we have to start by doing the sine of 4 pi over 3 and seeing what that is. So the sine of 4 pi over 3, locate 4 pi over 3, which is here. The sine is negative square root of 3 over 2. Okay, now what happens on this one is you're going to do the inverse tangent of negative square root of 3 over 2. Now, you're not going to be able to figure this out on a unit circle. The only choice you have on this problem is to use a calculator, because the tangent of theta is y over x. And y over x, getting a negative square root of 3 out of 2 over that, you're not going to get that with any of the special angles that are on a unit circle. Okay, so what I'm going to do on this is I'm going to have to go ahead, and I want to show you a couple things on the calculator on this. I'm going to take my, I'm in degree mode, which is what I want it to be for now. So if I go inverse tangent, and if I put in negative square root of 3 over 2, notice what I'm going to get. I'm going to get an angle that's not one of those special angles on the unit circle. So that's how I know to do this problem that way. So what I'm going to do is I'm going to go take my mode back to radians, because I want my angle answer to be in radians. Then I'm going to go inverse tangent of negative, I'm sorry, you got to put the negative in first here. So I've got negative square root of 3, and divide that by 2, and this will give the answer of the problem, which is going to be about negative 0.71. Okay, and that's good enough for that. Okay, all right. So all of these problems could be checked on a calculator too. So what I want to show you on this, I want to put my calculator back in degree mode, because I think it's easier to check this way. Or actually, let's leave this in radian mode. I changed my mind. So let's go back. Let's just do problem A. So what we would do is inverse sine of cosine of pi. We're in radian mode. And what it's going to do is it's going to give us the decimal equivalent of our answer. So if I put in negative pi divided by 2, that verifies that that's the right answer to the problem. So all of these things are checkable. Next one, you could go inverse cosine of the sine of pi over 3. Like this, that'll give you this answer. And then just take our answer, which is pi over 6, and see if it matches up. Okay, so it's really easy to do these on a calculator. The reason you're trying to learn how to do this analytically is it helps you make connections about the unit circle, about the definitions of the trig functions, knowing what the range of the inverse trig functions are. And that stuff is all important for higher math. We're not just plugging things into a calculator and getting our answer. There's a lot more to it than that. Okay, down at the bottom of the page, now these are some things we're going to do without a calculator. Again, you don't really need the unit circle on this. The difference between these problems, I want you to notice, is all of these problems we just did, the outer function was an inverse trig function. But if you look at what we're going to do, the inner function is an inverse trig function now. So what we're going to do on this is we don't really need to do a unit circle. We can analyze it just knowing the values of x, y, and r. So the first thing we're going to look at on this problem is look at the inverse trig function. The range of an inverse sine is bracket negative pi over 2 to pi over 2. So if you're dealing with an inverse trig function, you're either in quadrant 1 or you have a negative angle that's in quadrant 4. Since this is an inverse sine of a positive number, that's going to force us to be in quadrant 1. And the way we analytically figure out this problem is, if you look at the inner function, it's really saying the sine of theta is equal to 4/5. By definition, a sine is a y value over an r value. So I'm just going to write down that y is 4 and r is 5. So if I'm going to do a cosine, I need to know x over r. So I'm going to use the Pythagorean theorem. I'm going to do x squared plus y squared is equal to r squared. That's going to give x squared plus 16 equals 25. That will give x squared equals 25 minus 16. So that's x squared equals 9. Square root both sides, you're going to end up getting on this, you're going to get x equals plus minus 3. But since you're in quadrant 1, x is going to be 3. So ultimately in this problem, you're doing the cosine of theta. That outer function is cosine, and the definition of cosine is x over r. So the answer to the problem would be 3 over 5. Okay, that's how you get that problem figured out analytically without having to really even think about values on a unit circle like we did the other ones. It's just a matter of finding x, y, and r. Okay. All right, the next problem. Look at the inverse trig function. Okay. Understand what the range of inverse cosine is. That's going from 0 to pi. And that would mean that if we're at 0 to pi, that would mean that we are either in quadrant 1 or we're in quadrant 2. We're dealing with an inverse cosine, our answers have to be there. Well, since this is negative, that means that we have to be in quadrant 2, because in quadrant 2, the cosine is the x value and it has negative values. So again, what we're going to look at in this problem is we're going to look at, this is really telling us the cosine of some angle theta is negative 2/3. By definition, the cosine is x over r. So we can write that down. X is negative 2 and r is 3. Remember, r is always positive. And we can use the Pythagorean theorem to figure out what y is. We're going to need to know the value of y when we do a cosecant. So we're going to have x squared plus y squared equals r squared. That will give 4 plus y squared equals 9. That's going to give y squared equals 9 minus 4. That'll give y squared equals 5. Do your square root of both sides. Technically, you'll have a plus minus square root of 5. But since you're in quadrant 2, when you're in quadrant 2, y is positive. So that's going to be square root of 5 like that. Okay, so ultimately what we're doing on this problem is we are doing the inverse cosecant of theta, which by definition is r over y. So now all we got to do is just take r, which is square root of 5, take y, which is, hold on, I did that wrong, okay? R is 3, okay, and y is the square root of 5. So you could write your answer as 3 over root 5, or the rationalized answer would be 3 times the square root of 5 over 5. Either answer is acceptable. You don't have to rationalize unless you are directed to do so. Okay, so see, that's how we're dealing with these problems, is we're dealing basically with x, y, r definitions of the trig functions. Okay, all right, so now let's do one more like this. And with this one, we're going to look at the inner function. The inner function on this is inverse tangent of negative 3/4. The range of an inverse tangent is parentheses negative pi over 2 to pi over 2. And what that means is you're either in quadrant 1 or you have a negative angle that's in quadrant 4. Now the tangent is positive in quadrant 1. Since we have a negative, that's going to force us to be in quadrant 4. Okay, so we analyze this way. We were really given the tangent theta equals negative 3 over 4. Now you have to kind of know where everything is on this. If we're in quadrant 4 and the tangent is y over x, so x is positive in quadrant 4, y is negative. So you have to reason that out. So y would be negative 3, x would be 4, and then r would be 5. This is a a 3, 4, 5 triangle. If you don't know that, you just go x squared plus y squared equals r squared, and you'd get 16 plus 9 equals r squared. You get 25 as r squared. And remember, r is always a positive number, so you would get square root of 25 is 5. And then the way you finish up the problem is you're ultimately doing a secant. So a secant of theta, by definition, is r over x. So r is 5, x is 4. So the answer to this problem is going to be 5 over 4. Okay, so that's how you analytically figure out a composition of functions, is like that. Now, you can check these on your calculator, and it actually doesn't matter what mode you're in. I'll prove that to you, because what the calculator is going to do is when it does like the inverse sine of 4/5, it's getting an angle. And that angle is either going to be in degrees or radians, depending on what mode you're in. And if you do the cosine of that, since you're in whatever mode you're in, it's going to give you the same answer. So in this problem, let's see, I'm in radian mode right now. So it's real easy to check your answer. You can just go cosine of inverse sine of 4/5, like this, and this will give you the answer, which is 0.6. Well, that's what 3/5 is. So if you do 3 divided by 5, that's going to give you 0.6. Okay, now let me prove this to you. So I'm going to move my calculator to degree mode, like this, and I'm going to do the same problem. So if I go through and if I do this, if I go cosine of inverse sine of 4/5, it doesn't matter what mode I'm in, I'm going to get the same answer. Okay, so all these problems can be checked. When you do the next problem, it's a cosecant. You don't have a cosecant button. So what you do is you go 1 over sine, because cosecant's 1 over sine. Then you put in inverse cosine of negative 2/3, like that. And that'll give you, whoa, I did something wrong on that. Did I put in, oh, I know what I did. So let me show you what you need to do on that. Oh, hold on. I did do that. Okay. I'm sorry. I was thinking the answer was something different. So let me do that one more time. I've got 1 divided by sine, parentheses. Now I'm going to do the inverse cosine of negative 2/3. And this will give me an irrational number. I was expecting it to give not an irrational number, but our answer was 3 divided by square root of 5. So let's see if that doesn't match up. And it does. Okay, so we're right. And then the next problem could be done the same way. You would have to just do 1 over secant of inverse tangent. So on this one, we'll go 1 over cosine of the inverse tangent of negative 3/4. And we'll see if that doesn't give the decimal equivalent of our answer. So it gives 1.25. Our answer was 5/4. Those are the same thing. Okay, so everything is checkable when you're doing this. But you want to be able to do this analytically. When you're doing another exam in this class, you'll do this without a calculator. Okay, last thing I want to do is, and I don't give homework on this necessarily, but this is something if you're a Calculus 2 student, you actually do from time to time. So what we're going to do is we're going to write each trig expression as an algebraic expression in terms of a variable u. The way to do this is to do a triangle. So this part right here, what this really means is it really means the tangent of some angle theta is equal to u. And I'm going to put that u over 1. And in a right triangle, the definition of a tangent is opposite over adjacent. So in my right triangle, I'm going to put theta there, and then I'm just going to write down what I have. The opposite is u, and the adjacent's 1, and then I would need to find what the hypotenuse is, which I'll just call r. So what I'm going to do is I'm going to do 1 squared plus u squared is equal to r squared. So that's 1 plus u squared equals r squared. I can do the square root of both sides. Now remember, this is a positive. We're talking about a triangle, so we're going to get a positive 1 plus u squared on that then. Okay, so ultimately we're doing the cosine of theta. The cosine by definition is adjacent over hypotenuse. So what you're going to look at here is the side adjacent is 1. The hypotenuse, we just figured that out, is 1 plus u to the second. So we end up having this as our answer to the problem. If you take Calculus 2 someday, you'll kind of work with a certain kind of a problem where you have to reason this out. Okay? So that's how you figure that out. All these problems are going to be kind of reasoned out with a triangle. Next problem, look at the inverse cotangent piece and just draw out a triangle. Okay, we'll have theta, and the inverse cotangent really means cotangent of theta, and that is equal to adjacent over opposite, and I'm giving you that is equal to u, and I'm going to put the u over 1. So in your triangle, the adjacent would be u, the opposite would be 1, and then you'd have to do the same thing. You'd do Pythagorean theorems. You'd have u squared plus 1 squared equals r squared. Take the square root of both sides, you're going to get the same thing. U squared plus 1 is equal to r. And this is a acute angle, so we're going to use a positive value. The hypotenuse is going to be positive. So ultimately in this problem, the sine theta is what we're trying to find. And the definition of a sine is the side opposite over the hypotenuse. Okay? So the hypotenuse we figured out is square root of u squared plus 1. So opposite's 1, hypotenuse is this. So we'll end up getting the same answer, 1 over the square root of u squared plus 1. Doesn't matter what order you put that denominator in. So that's how you reason that out. Okay? All right, next one, we're going to look at inverse sine. And what this ultimately means is the sine of theta is equal to u. I'll put that over 1, and the definition of a sine in a triangle is side opposite over hypotenuse. So we're going to make a triangle, just draw an acute right triangle with an angle theta. The side opposite will be u, the hypotenuse will be 1, so this time we have to really find that value, okay, which I'll just call that x. So what we would do is we would do x squared plus u squared is equal to 1 squared, Pythagorean theorem, so I rewrite this as x squared equals 1 minus u squared. I do a square root of both sides, so I'm going to get x equals square root 1 minus u squared. We're just going to use positive numbers on these. So what we'll have is ultimately we're doing a tangent. The tangent of theta by definition is opposite over adjacent. Okay, so the opposite is going to be u. The adjacent will be what we found x to be. So that will be u. Answer to this would be the side adjacent, or side opposite, which is u, and the side adjacent, which is square root of 1 minus u squared. Okay, so that's how you put that together. Okay, so that will be in the video on this, and the main thing you want to be able to do on this is work with inverse trig functions and the composition of functions. Okay, good luck.